Hi Prof. Yo, we're Group 7 and I'm Joseph. Together with me are Nicole, Yuan, Bradley and Conan. And together we're going to explain the topic of functions using boxes. Now this topic can be dry or boring just like stale bread. But no fret, we will make it fun for you. So without further ado, let's get right into it. Oh, they're gone. Let's get right into it. So in our example, we'll be using boxes to help explain functions. In this example, we have the function fx equals to x squared, and we'll be using the input x equals 2. Now when I put this input inside the input hole right here, and now of this output hole is one output, fx equals 4. So the basis of our function is that when you input one input such as that, only one output will come out. And in this example, when I substitute the input x equals to 2, fx will be 4 because 2 squared is equal to 4. Now that is the basis of functions.
Hello Prof. Yu, I'm Nicole and I'll be explaining domains in a function. So what's a domain? A domain is all the possible inputs for a function, and you can think of it of what can or cannot enter this box here, fx equals to square root x. So for example, in SIT you have the gantry system where SIT students are allowed to enter. So for example, x equals to 4 over here is a valid input for this expression here. So when I put it in, I get fx equals to 2. However, we cannot say the same for x equals to negative 4. As you can see here, x equals to negative 4 is an invalid input. So when I try to enter this here, you realize that this box is too big to fit into the domain. So what does this mean? This means that fx equals to square root x only accepts 0 and positive numbers. Thank you, Prof. Yu.
Good morning, Prof. I'm Yuan, and I'm at the iconic SIT Red Bridge. Today, I'll be explaining the concept of composite functions, which is a combination of two functions. So to start off, I'll feed the value x into hx, and it will produce hx for me. Simultaneously, I'll feed hx into gx, which will give me g of hx. But the order matters. As I mentioned before, sequence matter. Hence, by using building blocks to represent hx and gx, I will join them from left to right. This forms g of hx. However, if I try to join them from the other way around, then this will not join to form g of hx. Thus, combining hx and gx together forms g of h.
Hi Prof, I'm Bradley. So what are inverse functions? An inverse function takes the output of a regular function and puts it as the input. In other words, it undoes what a regular function does. So here we have our setup where we have times 3 and plus 2. So we take the input, which is x, we put it through, we get 3x. And put in through the second part, we get 3x plus 2. And then for our inverse function, we have minus 2 and divide by 3. So we take the output from earlier and we put it through of 3x plus 2, and we come up with 3x. And put it through again, we get x. So for the notation of an inverse function is inverse of fx, which is contrary to the regular function, which is fx.
Hey, fancy seeing you here, Prof. Yu. I'm Conan, and welcome to SIT Toilet with a View. And today, I'll be tackling tutorial 3, also known as the question with too many square roots. The question we'll be doing will be square root 1 minus square root 2 minus square root 3 minus x. So to start off, we'll split our functions into 3 distinct parts, and x will be equal to 2 for value. So to start off, x equals to 2 goes into our input of our first part, and output will be gx equals to 1. And the output of the first part will go into the second part, which will give us the value of fx equals to 1. And the output of our second part will go into our third part, which will give us the output of hx equals to 0. Thank you, Prof, for watching our video. I hope you enjoy it.